Hi everyone. Today I will introduce a new database that integrates biotic and geochemical data to explore drivers of evolution and ecological change, and that is the Panama Paleontology Project database. So the PPP, or the Panama Paleontology Project, was funded by Jeremy Jackson and Anthony Coates 30 years ago, and within the project thousands of samples have been collected and more than 120 researchers had participated in it, studying the nature, timing, and magnitude of evolutionary events associated with the closure of the Isthmus of Panama. More importantly, the PPP established that quantitative, rigorous, multidisciplinary, and systematic sampling and analysis of the fossil record can reveal fundamental ecological and evolutionary processes that mold the history of life in biodiverse tropical seas. So, although the PPP project was very successful on understanding the paleoecological and microevolutionary patterns and processes within a rigorous biological framework in the tropics, the approach led to an isolated analysis, so now is necessary a synthetic analysis of temporal and spatial changes across entire biological communities. So to achieve this, we built a relational database to unite paleobiology, ecology, oceanographic, climate, environmental, and geochemical datasets to allow broad-scale comparison and analysis of marine ecosystems and their communities. So, which is the concept of a database? So, it's to store and organize data efficiently and make the data retrieval efficient to use. So, why a relational database? Well, data is organized in related tables. One or more fields are linked to fields in another table, and links ensure that you can enter only those values that have corresponding entries in other tables. So related tables help reduce data redundancy. So we are using MS SQL Server System that is compatible with Microsoft Jet database, that is an engine tool necessary for web access, that is the goal for the near future, and all this is including access. So, okay. So a database needs to be carefully planned with interoperability in mind, and is necessary to determine the purpose of the database, but also you need to have a real understanding of the data and not just an abstract knowledge of it. So for our database, we have categories, and the categories that we have are localities, geology, sample, environment, taxonomy, traits, specimens, abundance, geochemical, and references. And for each of these categories, we need to think about which tables are linked with these categories and which information you want to store on each table. So if I take an example, the category geology, the tables for that category are time scale, stratigraphic unit, stratigraphic section, sedimentary characteristics, funnel, and age. And then for each table, you need to think which fields are necessary for the tables. So for stratigraphic unit table, we assign fields like time scale, group, formation, member, sequences, and remarks. So the database needs to be structured in a way to increase the potential future use. So, well, you don't see anything here, but this is the flow chart of our database. So we have the categories that I mentioned before. within those categories, the tables for each category, and then the relationships within and between tables. So the relationships are used to extract data from several tables at the same time, and these relationships can be one-to-one, one-to-many, or many-to-many. So at the moment, we enter into the database 276 localities that includes modern and fossil samples in both the Caribbean and Pacific side. We have 4,660 samples, including hundreds of bulk samples of neogene sections, hundreds of grab samples in the Caribbean and Pacific side, and thousands of dredges and hand samples. We have 2,376 taxa with fish otoliths, gastropods, bivalves, corals, bryozoans, shark teeth, and cupuladrids. We also generated high-resolution, stable isotopic carbon and oxygen profiles, roughly 4,000 analyses of conus and strombus shells. And the database, the PPP database, is linked to R, that, as you know, is a free software for statistical analysis. So here so to link the database with R, we use the package RODBC. So here is the name of my database, and then if I ask for all the tables and queries that are in my database, I can see it in R. So with this, it's possible to explore the interactions and associations between different taxonomical and functional groups, their abundances and geographic ranges with environmental change through geological time. So now I will show you just basic uses of the database. So if I want to know the number of samples over time, I build queries in the database using the tables of fonial, sample, taxon abundance, and taxonomy. And that can be calculated for any time being. In this case, is 1 million years. But we create a module in Microsoft Visual Basics where you are able to choose any interval of time, so 0, 6, 3, 6 million years. So with the table of number of samples over time created in the Access database, you can export in R and do any kind of graph that you want, as well as you can calculate the number of samples by fauna or the species richness. And you also have you can also choose which rank and which taxon you want to do it. So in this case, I choose at genus level, and the taxon filter will be Bivalvia, and here is the results. Also, species richness, you can create queries in the database or even in R using different packages. In this case, we use vegan package. And as you see, you obtain the same results in both methods. So as I show you, the PPP has an unprecedented breadth of sampling. Moreover, the PPP biotic samples and environmental data come from the same sites. Plus, we produce a unique resource that opens up a world of opportunities to explore fundamental questions of environmental and biotic change in the tropics, such as what drove evolutionary turnover in tropical America, how do marine communities respond to environmental change, and pinpoint the date of formation of the Isthmus of Panama. So also we are extremely interested to integrate our database with the paleobiology database, worms and ovis. So as I show you, a database are a collection of data and the organizational structure in which those data are stored and organized, along with the means to usable retrieve subset of information. So a database is an important tool to have updated, safe, and available data for long term. In order to have this, a longer term plan is to have a freely online access to it. And well, the database will look something like that, that is very friendly end user. And ultimately, the PPP database will be a powerful and open tool for paleontologists to study patterns of extinction, origination, ecology, and biogeography within a rigorous environmental setting from the most important tropical paleontological collection in the world. Although the database was intended for only the Panama Paleontology project, the database now has grown exponentially and is intended eventually to cover not only marine fossil record but also recent for all tropical America. So we came up with a different title for the database, something like Tropical Ocean Database. So we are open for any suggestions or anything. So thank you.
We have time for some questions, if anyone has any. I guess it was very, very clear.